As global warming is playing a role in desertification, addressing issues surrounding climate change will play a necessary role in controlling the expansion of deserts into inhabited areas. The excessive consumption of fossil fuels from the start of the Industrial Revolution up to the modern day has released enormous quantities of CO2 into the Earth's atmosphere. Although also other greenhouse gases play a role in this phenomenon, the biggest role is played by CO2, and we will focus on it in this video. As some efforts to reduce carbon emissions are already in place, and others have proven unsuccessful, it becomes more and more clear that carbon sequestration is a necessary part of the equation if we want to invert or at least stop carbon emissions. The initial attempts to capture carbon from the air involved reforestation initiatives. Some were driven by pure environmental enthusiasm, while others aimed to earn money through selling carbon credits. Carbon credits are like eco-friendly certificates earned by projects that remove carbon dioxide. These credits can be sold to individuals or companies looking to offset their own carbon footprints, thus providing financial support to carbon sequestration projects. This financial support could become a crucial source of money for carbon sequestration projects in drylands too. When I was doing the research for this video, I was convinced that a larger amount of organic matter in soil increases the available water capacity. However, that belief was proven unfounded. Minesny and McBratney state that it is widely accepted that the available water capacity in soil can be improved by increasing organic matter content. However, the increase in amount of water that is available to plants with an increase in organic matter is still uncertain and may be overestimated. Conversely, global warming may cause losses in soil carbon, but the effects on soil water storage and its consequent impact on hydrological cycling might be less than thought previously. A 1% mass increase in soil organic carbon on average increased available water capacity by 1.16% volumetrically. Let's therefore discuss the carbon sequestration potential that soils represent. According to Lal, in the article Soil Carbon Sequestration to Mitigate Climate Change, measured rates of soil carbon sequestration to adoption of RMPs range from 50 to 1000 kg per hectare per year. The soil carbon sequestration is a truly win-win strategy. It restores degraded soils, enhances biomass production, purifies surface and groundwaters, and reduces the rate of enrichment of atmospheric CO2 by offsetting emissions due to fossil fuels. The methods Lal presents are tied to agriculture. However, we are interested in how architecture and human settlements can play a role in this. Architecture focuses on creating individual houses, while urbanism plans entire human communities. These places play a crucial role in the carbon cycle through activities like our food consumption, waste production, heating methods, and even the packaging and construction materials we use. Elements such as our diet, energy choices, and packaging materials can contribute to the release of carbon into the environment. While currently these have a negative impact, in a more proactive future, some of the carbon that is generated by these activities in the form of waste has the potential to be sequestered into our soils. To achieve these goals, we need to shift some of our habits and produce products meant to achieve carbon sequestration by design. What are the promising technologies that could help us achieve these goals? Hydrothermal carbonization is a process that involves transforming organic materials using heat and high pressure in water. In simpler terms, it's a method of turning things like agricultural waste or even sewage sludge into a type of charcoal-like substance through controlled reactions in a watery environment. Considering that it heats the material to temperatures high enough to kill off all pathogens, it could have an important impact on the future of sanitation and the processing of carcasses and meat and fish waste, which was unsuitable for conventional composting. While the solids created in this process can be applied as sequestered carbon directly into the soil, the liquid phase is rich in plant nutrients and will have potential applications as a fertilizer and in hydroponics. Biochar is a type of charcoal made from organic materials like agricultural waste or wood chips or cardboard. It's created through a process called pyrolysis, where these materials are heated in low oxygen environment. Biochar can be used to improve soil quality, retain moisture and store carbon in a stable form, making it a valuable tool for both agriculture and environmental sustainability. According to Tengain in their article titled Biochar Mines, Panacea to Climate Change and Energy Crisis, they claim negative emissions technology such as bioenergy with carbon capture and storage is extremely important to offset the presence of atmospheric greenhouse gases. Biochar, a solid product obtained from the thermal decomposition of biomass, is a promising pathway for the storage of solid carbon and energy applications. As it is generated in a combustion process and is energy positive while being carbon negative, if the biochar is then applied to soil, this really could change how energy production links to carbon emissions. I like imagining a small biocharing stove as the first step towards a bigger scale implementation. I imagine this would consist of a chamber in which the charring material is added from outside on one side, holes on the bottom of the container that allow combustible gases to escape and get ignited in the fire below, a combustion chamber under the biocharing box, and a cooktop above the box, an air inlet and ashtray at the bottom, and a smoke pipe that connects to the house's chimney complete the project. I would love to contribute to designing an object such as this one. While being a technology that is already widely available, compostable or burnable packaging materials that we can use in our compost piles, or maybe even as fuel for these future biocharing stoves, is a trend we need to further endorse and implement throughout more and more sectors, and then actually set up the systems to collect and compost them on a large scale. Considering how unable we have proven to be as humanity to reduce our carbon emissions so far, I really have big hopes in these technologies and that they will have an impact both on how we live in the future, on our everyday life, and maybe they can help us contribute a more carbon neutral or even a little bit carbon negative future. I really do hope that that will be the case.